Hello 3U, we are on our day 1 of our quadratics unit and I'm expecting this is going to go very well. First of all, because I'm eating Oreo cookies while I record this and that's helping a lot. We also did a unit that involved a lot of algebra, so those skills are back up. Our first unit in functions also has our graphing skills and our expansion and compression skills honed, and so we should be good to go with something that's so familiar as quadratics. In our Unit 1, we talked briefly about parabolas, that the parent function for a quadratic is y equals x squared, and it will graph as a curved parabola. When we do compressions and expansions and many transformations, it would take on the form y equals a x minus h squared plus k, which we're also familiar with. A is a vertical change. If a is negative, we have a reflection vertically across the x-axis. Flip upside down. If the absolute value of a, or its magnitude, is between 1 and 0, in other words, it is a fraction, we have a vertical compression. If the magnitude of a is greater than 1, a larger number, we have an expansion. Vertical is as it would seem. This will alter your step pattern when drawing your parabola. All of the verticals, or the ups, will be altered. Okay. The K is also a vertical change. It's a vertical translation. If K is greater than 0, we're adding a number on. It is a vertical translation up. If we're subtracting or we're adding a negative number, your vertical translation is down. H is a horizontal change. It's within the function or the brackets. Because it's in the brackets, if we are subtracting h, we would be going to the right. If we would be adding a number, that's like subtracting a negative number, that would be to the left. Notice that we haven't included any horizontal compressions or expansions. Say a silent thank you there. Let's take a second to graph two parabolas and talk about the key features of parabolas. Y equals minus 2, x plus 3 squared plus 6. So quickly I'm going to write down the different transformations that have taken place on my parent function y equals x squared. This should be recall from grade 10. The negative says it's a reflection across the x-axis. In grade 10 we would have said it's upside down. The 2 tells us that it's skinny. It's a vertical stretch. Sorry, a vertical expansion. It's a better word. Factor 2. That means all of my step pattern verticals, or my ups, in this case downs, would be doubled. Double down KFC. All right, so that takes care of the negative 2. The plus 3 is a horizontal change, and because it's plus 3 in the brackets, it means to the left 3. The 6 is also a vertical change, and because it's a plus 6, it's up 6, as we would expect. From grade 10, we looked at that form, which is called the vertex form, and would have noticed that my vertex is left 3, up 6. Let's graph it. My starting point is negative 3, 6. My step pattern is go downwards. Instead of over 1 down 1, it's going to be over 1 down 2. All of those steps are doubled. Instead of going back to the vertex, over 2 down 4, it's going to be over 2 down 8. It would not be a harmful thing to write the, quote, normal step pattern so that when you double it or half it or triple it, it's immediately obvious what you're doing. So let's write over to the side, normal step pattern, so that we can draw it quickly and efficiently. So I'm talking about y equals x squared, our parent function, is normally over and up. In our case, it will be over and down. And the normal step pattern, always from the vertex, would be from 0, 0, over 1, up 1, back to 0, 0, over 2, up 4, back to 0, 0, over 3, up 9. When we doubled our step pattern, all of these would be doubled. So from the vertex, I went over 1 down 2, over 2 down 8, over 3 down 27. Nope, sorry, 18. Hello. I just didn't fit that in very well. There is our graph. Let's make a list of the key features. We have already talked about the vertex. And the vertex in this form is lovely. It comes from here and here. And we need to think left, right carefully, and the ups, downs to come up with our vertex. There are other key features that we talked about in grade 10. One was the axis of symmetry. The axis of symmetry is the fold line, and the fold line always goes right through the middle of that parabola. And parabolas always fold nicely exactly in half. That axis of symmetry is a vertical line that goes through the vertex. Since it's a vertical line, it's going to be x equals, oddly, and it will always be the x value of your vertex, x equals minus 3. Another key feature would be the y-intercept. The y-intercept is where my parabola meets my y-axis, and I didn't draw mine far enough to eyeball it, which is fine. We shouldn't trust our eyes. To find a y-intercept, the most accurate method is to substitute x equals 0 into the equation and solve. If I put a 0 there, if I put a 0 there, I have just a 3 in the brackets. 3 squared is 9. Minus 2 times 9 is minus 18. And minus 18 add 6 is minus 12. My y-intercept is as a point 0 minus 12. Lastly, x-intercepts are a very important key feature. Some parabolas have no x-intercept, some have a double single x-intercept, and some parabolas have 2. This particular parabola has 2 x-intercepts, one here and one here. Eyeballing them, it looks like one of the x-intercepts is minus 1.25, comma 0, and the other one is minus 4.75. I am absolutely convinced those two x-intercepts are not correct because I am using my eyes to determine them. We're going to have to come up with a better method to get x-intercepts. The second parabola we're going to look at is y equals a quarter, x minus 2 squared minus 5. From my lefts, rights, my horizontal and vertical translations, I know that my vertex will be 2 to the right, 5 down. That means my axis of symmetry will be always the x value of the vertex. That will be my fold line. I'm also going to look for my y-intercept. I haven't even drawn it yet, but to find a y-intercept, your best method is to substitute x equals 0 into the equation. Putting a 0 into that bracket in the correct place, I am left with minus 2 in the brackets. Minus 2 squared is 4. A quarter times 4 is 1. And 1 minus 5 is negative 4. My x-intercepts, I don't know how many I have, and I don't know what they are. I will eyeball them in a little bit, but I am looking for 0, 1 of them, or 2 of them. So we're going to eyeball those. Never the best method for solving things. We'll come up with some good methods in a few days. To graph this thing, my vertex is 2 minus 5, right here. My step pattern has been altered by a quarter. I'm going to write my step pattern down. It is normally over and up. Since I don't have a negative out the front, it will still be upwards. My normal step pattern is from the vertex. I know there are different ways of doing step patterns. Over 1 up 1, over 2 up 4, over 3 up 9. You can see squared numbers here. My step pattern has been altered by a factor of a quarter. Some of them are going to be ugly. Okay. From the vertex, I am going to go over 1 up a quarter. You can do better on your graph paper. There we are. From the vertex, over 2 up 4 times a quarter is 1. I'm going to do one more. Over 3 up 9 times a quarter is 9 quarters, which is 2 1/4. There we are. Should be a wide upwards parabola. Okay. It is altogether possible and very likely that those are not correct. But very approximately, my x-intercepts would be, and it's good to write them as points, 1, 2, 3, 4, 5, 6 1/4, 6 1/2, and negative 2 1/4. But I am convinced, because it opens upwards and has a vertex below the x-axis, that I do have 2 x-intercepts. Because this one opens upwards, it has a minimum value. There is nothing below that on my parabola. So there is a minimum value of the y value of the vertex, which is minus 5. My other parabola has a maximum at the vertex because it opens downwards. It has a maximum value of, where's my vertex? 6. Always the maximum is the y value of the vertex. It is particularly easy to graph when we have our equation in that form. In vertex form is what we were working on before. You can see the vertex, you can see that it's upside down and skinny, and you can graph it quite easily and find all of the key features, except for the x-intercepts. This is called x-intercept form, and as it suggests, it is very easy to find the x-intercepts, and a little bit more work to find some of the other features. We looked at a third form as well. Y equals ax squared plus bx plus c is general form, and it's just hard to find most everything. It is easiest to find your y-intercept, it's just the c, in this form. It is easiest to find x-intercepts and proceed from there to find everything else in that form. This one is easiest to find the vertex, and many other things in that form. It would serve us well to hone our algebra skills to be able to go back and forth between the different forms. To go from this form to that form, we need to be able to expand. From general form to x-intercept form, we need to be able to factor. Then it gets tricky. To go from vertex form to general form, we would also expand, just being very careful. To go from general form to vertex form, we are going to complete the square. I have your course notes 21 open in front of me, 8.5. I would love to do a couple of those together. Get you to start with that before you go on to the textbook, page 145. Course notes 21 gives you the equation and asks you for some of the key features. So y equals 2x squared does not have a negative sign in front, so it will open up. Normal, stretch, shrink. Y equals 2x squared has a vertical expansion, factor 2. Expansion is the word we're looking for. There are no left-right changes. There are no brackets to indicate there's been a horizontal translation. Vertical up or down is when we add a number on the end and there is not a number subtracted or added on the end. A vertical shift is not applicable. The vertex, therefore, has not moved left to right, up or down. It is the normal, in quotes, vertex at 0, 0. So we are always comparing to y equals x squared, our parent function. I'm going to go down to number 7. Y equals minus a half x plus 2 squared. Okay. There is a negative. It means a vertical flip across the x-axis. So our reflection will be downwards. There has been a vertical compression. I'm trying to use the same language that we used in Unit 1. Vertical compression, factor 1/2. It will be wide looking. There is a horizontal translation. It's in brackets. My horizontal translation is 2 to the left. There are no add-ons at the end or vertical translations up or down. My vertex, therefore, is a 2 to the left and no changes vertically. My vertex is minus 2, 0. Number 9. There is no factor A at the beginning, so there's no negative to open it downwards, so it is an up. There is no vertical compression or expansion in front of that function, so there is no expansion or compression. We would say that's normal compared to the parent function, y equals x squared. There has been a left 3 in the brackets, is my horizontal translations. And at the very end, there is a negative 4, that is a down 4. My vertex would be 3 to the left, down 4. Other things to keep in mind as you're having a look at these is, what would my axis of symmetry be? Would I have a max or a min? And how can I find my y-intercept? Some of your textbook questions will address those a little bit more, but let's look at number 9. Sorry. The axis of symmetry always goes through the vertex, so it would be x equals negative 3. This one opens upwards, so it will have a minimum value. And your minimum value always comes from the vertex. We have a minimum value of minus 4. The y-intercept is when I substitute x equals 0 into the equation, and I would get 0 plus 3 is 3. 3 squared is 9. 9 take away 4 is 5. To write it as a point, it would be 0, 5. Please fill out course notes 21. Should be super easy. And then in your textbook, page 145, numbers 1 to 9. 11, and 15. Enjoy the familiarity of quadratics.